Hello, and welcome to PLCcable.com. If you're looking for great prices on OEM and aftermarket supplies, then you've come to the right place. In this video, we are going to be covering our new and updated PID trainer. First, we'll be covering the features of the trainer. Second, we'll be covering the setup and operation of the trainer. Third, we'll be covering the sample PID logic that we supply with the trainer using RSLogix 500. The goal of the PID trainer is to teach people how PIDs work in the PLC, how to tune the PID loop, getting familiar with the PID setup screen, covering some of the math instructions, timers, counters, moves, scaling, and much more. If you're looking for help with just the RSLogix 500 PID and PLC programming logic, you can skip forward in the video. Later, we will be covering the basics of setup and what you need to know to get your PID working. With our PID trainer, you do not need one of our PLC trainers, but you will need a PLC, any brand of your choice, with 2 spare isolated digital 24-volt outputs, either relay or transistor, analog with 1 analog input 0 to 10 volt DC, and 1 analog output, also 0 to 10 volt DC. For our video, we are using our micrologix 1400 deluxe trainer and a micrologix analog I/O expansion card. The part number is 1762IF2OF2. We could have just used the analog I/O built into the PLC, but we are using them on our trainer, so we needed to add the extra analog I/O card. First, we will cover the features of the trainer. Located in the base of the trainer, there is a variable speed fan that you will control the speed of to make the ball raise and lower. There's an electrical damper at the bottom of the tube. We will use this damper to simulate process fluctuation and also process variables. There is also a damper, a manual damper, at the top of the tube that is for process fluctuation and setup. The lower damper is controlled via the PLC and or manual open and close buttons on the trainer. At the top of the tube, there's a positioning proximity switch to give the PLC a feedback as to the location of the ball height. In our PID, we will put the set point at 50%. This means the PID loop will try and keep the ball in the middle of the tube regardless of the position of the upper and lower damper. On the left side of the trainer, we have 2 meters. One is for the ball height signal, and the other is for the fan speed signal. On the right-hand side of the trainer, we have incorporated 2mm banana plugs for easy wiring of the trainer. We also supply all the wires you will need to hook the PLC trainer up to your PLC. Okay, now let's move on to the setup and wiring of the trainer. The trainer runs on a standard 120 volt AC. If you're buying this and you're one of our international customers, you will need to buy a simple US to EU power adapter. The trainer has its own built-in 24 volt power supply, so you just need to supply the 120 volt AC. The top 2 plugs are your DC to run to your PLC for the digital outputs. The short black wires are all connected as your DC common negative. The damper open is coming from the PLC output, and when energized, it will open the damper. Same with the damper closed. When energized, it will close the lower damper. These are the yellow wires. Blue is the common positive that you're supplying to the PLC for your voltage. Here we're showing the other end of the wire that's connected to the micrologix 1400. The blue wire being the common positive connected to the relay outputs. The yellow are the outputs sending voltage back to the PID trainer. So when the logic is true or closed, it will either open the damper or close the damper. Next, we have the fan control and proximity feedback. This will be the 0 to 10 volt signal coming from the PID trainer to your PLC for a ball height, location, and to control the fan speed. You will need to connect the proximity switch positive to your analog input. Next, your PLC analog output will be connected to the PID trainer at the positive fan control. This will control the fan speed. It will also be the output of the PID in the logic of the PLC. You will also need to connect the black wire to your analog card for the analog common negative. Once that's complete, you should have everything wired up and ready to move on to start your logic. Double check all your wiring to make sure that you have everything wired correctly, and use a meter to make sure you have no shorts. So now let's go ahead and move on to the logic that we wrote for the trainer, and that's going to be for the sample that you're going to receive. The top rung we'll cover later. That's going to be for the auto damper position, and so it just fluctuates. Basically what it does is it fluctuates so that way it changes your variable, and so you can see, let me see if I can scan it. This damper here is the automatic one. You'll see right there by the black line that it's in the just about the fully open position. And what we'll do in the program later on is we'll take that damper and we'll close it or partially close it and then open it back up, and that way you're changing the variables. We have two variables on here, the lower damper and the top and then the upper damper, and by changing those two dampers you can change the amount of airflow that can pass through the tube, and that'll change the ball height that you're actually running at. But your PID should make up for the variables and be able to maintain that 50% level that your set point's at. So if we're trying to maintain the ball in the middle, regardless of the lower position of the damper or the upper damper position, the ball height should maintain somewhere around the middle. It's going to fluctuate a little bit, and that also has to do with the setup of your PID and how well you have it tuned. So that's the top rung. The next rung is going to be the scaled ball height. So that's our input. Oops. Here, this is that's our binary value of it. This is going to be our digital value of it, and that's our raw number from our proximity switch. So the proximity switch at the top of the tube is telling us right now we're running at roughly 16,000 value coming into the PLC. So if we look at it, it's roughly, if you look at it here, it's roughly about halfway. And that's because right now we're online and our PID is up and running, and so what it's doing is it's trying to maintain that level. So with our fan shut off, our input minimum is 600. And I just verified that by going online with the PLC, looking at our input, shutting the fan off, and we read 600. Our input maximum is 31,150. So with the fan speed at 100% and the damper is open, so the ball can go all the way up to the top of the tube, the value that we're getting from our sensor is 31,150. Our scaled minimum, because what we're trying to achieve here on these two is 0 to 100 as a percentage. And that's what we're going to do for looking at our tube. We're going to say we want it to run about 50%, which is going to be the center of the tube from top to bottom. Maximum is 100, 0 being the bottom, 100 being the top. That gives us an output here, which is the ball height. And this should be running from anywhere from 49 to 51 if we have a good tune. And that's just what it's going to try and maintain regardless of the damper position. Our PID is on the next rung down, and that's going to be our PID 9. And this is what we set up. Two ways of looking at this. You can look at it here and see all the data, or you can go to the setup screen and see it here. Our set point here is 50, so that means we're trying to maintain that center. If we set it at 25, it's going to run down here. 75, it's going to run up here. We're not. This is a video, so we're not going to be able to show you that, but you get the idea of it. This is the PID settings. You have 3: proportional, integral, and derivative. This seems to be a pretty good tuning for this setup that we have here. There's a lot of other things that you can do excuse me, with the flags in the PID. And if you want to get it to run better and have a better loop, you can click on the help. That'll explain a lot of the information that's in here. Then at the bottom, there's another one that you can for the flag. And then this covers all your flags. And you can just use that to help you run your PID and have a better PID loop. Then we take our output. So this is our PID address. This is our input coming from this scale parameter. Our output goes to this one here, and then we do just the opposite here. So we set up our scaled minimum with 0 to 100. Scaled minimum is 600. Our maximum, same thing as up here, is 31,150. And then this is our raw number going to our fan. So running our fan at the specific speed that we want it to, and this is the raw value of it going to it. 0 to 10 volt fan, a 0 to 10 volt potentiometer giving us our feedback. So right now we're running the fan, if you look at it here, about 35% to maintain, 36 somewhere in there percent to maintain that ball at the correct height. So what we're doing on this here, if the switch is in the closed position, then that enables our auto bit. When our auto bit's enabled, then that's when we go ahead and, if it's not enabled, we can use these two toggle. These are the two push buttons on the actual trainer, or on our PLC trainer. Let me see if I can get a picture of it. Over here is the PLC trainer. That's going to be these two push buttons, the green push button and the red push button. Also on the PID trainer, there's a green push button and a red push button. So in manual, you can run these two, or you can run these two, either one. In auto, it's going to be closing and opening the damper itself, depending upon how the logic is. So what we're doing is we're taking a timer value, and this is just a bit inside the PLC that cycles on and off. We're running that to a counter. with a preset of 10. Then we're taking another equals to. And so whenever we hit here, if it equals 10, this will reset this counter. So these two rungs are just running a loop and cycling a timer. And then what we're going to do is later on in this next two rungs is we're going to use that value. If our auto is closed, which is that top rung, and our timer here, a cumulative value is less than 5, which is our set point, or our preset, is less than 5, our damper open output will be enabled or true. And so that'll be trying to open the damper from anything from 1 to 4. Am I saying that right? Yeah, less than 5. So 1 to 4, this is going to be true. Here we're doing just the opposite. So greater than 5. So 6 through 9, we're going to be closing the damper. Now these aren't a true mirror image of itself, or else the damper would be going open and closed to the exact same position every time, and you wouldn't have really much fluctuation. Because these actually time different or count different, they'll be running it, and you can hear the fan speed. Let's see if I can enable that one. All right, that's with the bit enabled. You can see the damper open, damper closed, damper open, damper closed, damper open, damper closed. Alright, what I did there was I just put it in manual and put it back to the normal setting. So now the PID is going back, and it should. Our damper positions aren't the same that they were before. So you can hear the fan speed is now up to 1700 or 17,000 is our fan speed. So to maintain that, now we were running our fan at 33. Now we're running our fan up at 55, and we're still maintaining the same level on our PID. And that's just going to give you another way of running it and trying to tune it better and make a better tune. What I did there was I forced it open. Want the damper to open up more to see if we can get our fan speed to come down. I'm going to change the top manual speed. Alright, so I changed the top manual damper. Now we're down to 40, 43, somewhere in there, to maintain that same 50%, which is up here. So we'll just go through the video. This is where it's running. These are the two manual positions, and then this is a manual setting on the fan speed. And as I push the open button, you'll see the damper right now is fully open. Now as I close it, you can see here that the damper's starting to close. So now the fan speed increases and keeps the ball at the given set point. And it should do that regardless of wherever your settings are. Then these are the two, the green and the red are the two push buttons that are in the logic down here. So if you push this green one or this red one, it'll also change it. Now since we open it back up, the fan speed slowed back down just to maintain that. And that's pretty good. It stays pretty level regardless of where that bottom damper is. Now you have the manual one up here that you can change to, along with the bottom one. So now you're adding two variables in there. You're changing the top one, the airflow, and changing the bottom airflow. And that fan's going to have to, the PID loop should work really hard and be able to maintain those two and maintain that level with those two fluctuating. Obviously, if you shut the airflow completely off, regardless of whatever your fan does, it's not going to be able to work at all. And that's it. If you got any questions, let me know. Thank you and have a great day.